Howdy! In this video, what we're going to do is classify polynomials by the number of terms, just to get a quick handle on the vocabulary that I may use as we multiply polynomials. We're going to multiply these 6 polynomials together in this video here. Okay, so first, real quick, if a polynomial has only one term, for example, maybe, I don't know, 3x to the 4th, right? That is called a monomial. If a polynomial has 2 terms, a term is a singular entity with multiplication, so it could be something of the like 2x, there's a term, right? Plus x to the 5th. That has 2 terms. That is called a binomial. 3 terms, a typical quadratic has 3 terms, right? So let's say negative x squared plus 2x minus 5. That one has 1, 2, 3 terms. That's called a trinomial. So I may use those words throughout some videos, okay? So in multiplying polynomials together, right? If you have, for example, say on this one, we've got a monomial out front. We have that 2x squared here, and it is multiplied by a trinomial because we have 1, 2, 3 terms. But there's only one factor out front. So we just distribute this 2x to everything inside. We multiply it by everything inside the parentheses like that, right? So 2x times 6x makes, we multiply the numbers and multiply the x's. So 12x squared, 2x times negative 3y makes negative 6xy. And 2x times negative 3 halves makes negative, the 2 times the 3 halves is 3x. All right, now if you have a binomial times another binomial, there's another video where I explain why FOIL does work, but essentially you take this and you distribute it to the x and you distribute it to the first term and the second term of the second parenthesis. But I'm going to jump straight into just simply foiling. I'm going to multiply the first 2 terms, the outside terms, the inside terms, and the last term. So we're going to do x times x. Those are the first 2 terms to get x squared. My 2 outside terms is x and negative 2. That makes negative 2 times x. My I is for inside. My inside term is 3 times x, so plus 3x. And my last term is 3 times negative 2. That's negative 6. And so we can combine these 2 middle terms. Those are like terms. They have the same variables. So we add the coefficients. Negative 2x plus 3x is positive 1x. We just write plus x and carry along that minus 6. All right, I'd like you to pause the video and you try the next one. 3x minus 4 times 3x plus 4. Okay, for this one, we are also going to FOIL, but something interesting will happen in this one, right? So 3x times 3x, we multiply the 3's to get 9. X times x is x squared. The outside term is 3x times 4. That's positive 12x. The inside term is negative 4 times 3x. That's negative 12x. And negative 4 times positive 4 makes negative 16. You may have noticed, right? The outside and the inside term, those are going to cancel. Negative 12x and positive 12x, those are opposite operations. They cancel out. So we get 9x squared minus 16. Well, why is that, right? You might go back and look at this original problem here. And maybe you notice that, hey, they're kind of similar, right? 3x, 3x, 4, and 4. The only difference is that one of them has a negative, the other has a positive. Anytime you have that situation, those outer and inner terms will always cancel, and you'll get what's called a difference of squares, which is it's useful to know when you go backwards and you're trying to factor differences of squares. All right, now I want to throw one in kind of like this, the 2x plus 5 all squared, right? Let me show you what not to do first. Please do not do this. This is not the same as 2x squared plus 5 squared. No, 5 squared, right? So what that means is, well, how do you square something, right? It's something times itself when you square something. So the right way to do it here would be to multiply the whole thing times itself. 2x plus 5, I'm just going to write it twice, times 2x plus 5, okay? And maybe I should write on here that is wrong, just to be clear. There we go. All right, now we're doing it the right way in green. All right, well, that you can see now, you're supposed to FOIL that. It's a binomial times a binomial. So the first 2 terms, 2x times 2x makes 4x squared. The outside terms are 2x times 5, and the inside term is also 2x times 5. You can write it twice, or if you're able, you can do that in your head. 2x times 5 is positive 10x. We're going to add that twice. If you can jump to plus 20x in your head, that's fine. All right, and then 5 times 5, that is 25. So those outer and inner terms do add together. So this simplifies to 4x squared plus 20x plus 25. All right, so those are some great examples of binomials and just distributing a factor out front, okay? From here, let's go on to two slightly more advanced examples, starting with 6x squared minus 2x cubed plus 1, all times x minus 4/3, okay? So there's three things multiplied here, right? You have a 6x, three factors, 6x. You've got this negative 2x cubed plus 1, that's a factor. And separate from that, you have x minus 4/3. That's also a factor. Now, you can really only multiply two at a time, so that's what I recommend. Now, if you think back to numbers, right, if you're multiplying numbers like 2 times 3 times 4, let's say, it really doesn't matter if you do the 2 times 3 and you get 6 and then multiply that by the 4 to get 24. Or you can do, let's write this out, right? I'm just making this up, 2 times 3 times 4. You can group those together and get 6 times 4. Or you could do, the 3 and the 4 first, you get 12 and do 2 times 12. But here's what you don't do. That's not equal to 2 times 3 and 2 times 4. 2 times 3 times 2 times 4. That would be inserting an extra 2 in there just because it's written first. Well, we don't do that, right? That's not right. So I'm gonna erase this stuff here. But anyways, the point is you pick any two you want to multiply together and then multiply your result with the thing that you didn't multiply in the first time. I think the easiest way here would be to just start with the first two. So let's group those together and multiply them up. So 6x times negative 2x cubed will be negative 12x to the fourth. 6x times 1 is positive 6x. Now I need to add parentheses around that because that entire factor is being multiplied by this other x minus 4/3. Okay, well now we do have a binomial and a binomial, right? We have 1, 2 terms, 1, 2 terms. So we'll FOIL this out, starting with negative 12x to the fourth times this x makes negative 12x to the fifth. Negative 12x to the fourth times negative 4/3 for the outside term. Negative times negative makes positive 12 times 4. Actually, well, let's do 12 divided by that 3 there, right? Because 12 divided by 3 is 4 times that 4. So positive 16x to the fourth. Then my inside term is 6x times x. Nice easy one, 6x squared. And last we do have 6x times negative 4/3. Again, I like to do the 6 divided by 3 first because that's 2. 2 times 4 is then 8. So we're going to get negative 8x. They kind of scan through and see if you have any like terms. Fix my 2 there, but no, I don't see any like terms. All the x's have different exponents. We have a 5, a 4, a 2, and a 1. So nothing there really simplifies. All right, so coming up on our last problem here, we have a binomial times a trinomial. I'll tell you what, I'm gonna actually move it down a little bit to give ourselves a little more room here. There we go. Okay, so we have a binomial times a trinomial. Actually, it's a trinomial first and then times the binomial, right? So what do? Well, we can't really FOIL that because there's not a clear 2 terms and 2 terms. There's not like an outside of terms and an inside terms anymore, right? So what do? Well, it's a pattern of that, right? So if you understand where the FOIL comes from, it's not hard to figure out that you're just going to multiply everything in the first group by everything in the second group. It's like you're distributing this entire 3 terms to this and then to that. And so what ends up happening, I'll just kind of go one at a time, right? I'm going to start with the 4x squared. We're going to do 4x squared times x. That's going to be 4x cubed. And 4x squared times 4. So the 4x squared times the 4 makes positive 16x squared. All right, I'm going to color coordinate this a little bit here. Now, next I'm going to move on to negative 6x. Negative 6x times x is negative 6x squared. See, I'm multiplying this middle term times everything over here in the second factor. And then negative 6x times 4 makes negative 24x. Right there, okay? And then we're going to go on to the next section, 3. 3 times the x is positive 3x. And 3 times 4 is positive 12. So we end up with a full 6 terms when we fully first expand that out. Okay, so I'm going to switch colors again. I'm rainbowing it today. sort of. Anyways, we're looking for like terms, and I like to just go in order of the highest degree term first. So we'll start with this 4x cubed, and I don't see any other x cubes, so that one's just as is. Let's see, these two terms look like we can combine them. 16x squared minus 6x squared, those are like terms. 16 minus 6 is positive 10x squared, okay. Well, also the next two terms, negative 24x plus 3x. Negative 24 plus 3 is negative 21. X followed by a plus 12. And that's it, fully expanded. So there's several polynomials all multiplied together, and also the classifications of those polynomials.